You might already have seen well, I guess not. If you've looked at the program, you see the trend. We have a lot of acronyms in this session today. And the next one is ProtoMF, prototype-based matrix factorization for effective and explainable recommendations, which will be presented by Alessandro Melchiorre. The floor is yours.
Thank you. So, hello everyone. As I've been already introduced, my name is Alessandro Melchiorre, and I'm a PhD student at the Johannes Kepler University, Linz, Austria. I'm very excited to be here to present our work on ProtoMF, prototype-based matrix factorization for effective and explainable recommendations. And this work has been done by me and my colleagues at the Institute, Navid, Rekabsaz, Ganhör, and Markus, Schedl. Recent studies in explainable AI, especially related to classification tasks, have shown that reformulating common machine learning models to the concept of prototypes brings new possibility for both effective and explainable machine learning. In particular, these models, these prototype-based models, when trained on a specific task and on a specific dataset, are able to explain their predictions based on the prototypes found in the underlying datasets. But what do I mean by prototypes? In the context of explainable AI, a prototype can be defined as a representative artifact that summarizes subsets of instances from datasets that share similar characteristics. For example, like in some studies, like on the mixed datasets, prototypes can look like specific digits, as we can see on the left, or even body parts of specific bird species when doing birds classification. And so what we do, actually, the goal in our paper was to enable this kind of prototype-based explainability in recommended system matrix factorization approaches by using prototypical users and items. In this context, like user prototype and item prototypes are basically characterized by various patterns of item consumptions and item features, and these characteristics are shared among the real users and the real items of the system. So let's see how this system may look like following the same framework that prototype-based approaches, but in AI applied to recommended system. So let's consider the input user and the input items. The system needs to estimate whether this pair is a good match for the recommendation. And let's focus only consider the user prototypes and still going by example on the music domain. So what could happen is that in this context, we may have several user prototypes that, for example, may embody the preference, the overall preference for a specific music genre, like the punk, grunge, and so on. And the first step in prototype-based recommended systems would be to then estimate the similarity between the input user and the several prototypes and generate this new representation. Now, this new representation for the input user basically has each component related to a specific prototype in the system. This representation can then be aggregated to generate the final prediction. Of course, this linear aggregation will take into account the item that we want to recommend. And the benefit of doing so is that now, following the system, we can trace back the prediction to the specific prototypes that contributed the most to the final prediction. Of course, considering also the item weights. So if we want to extract a simple textual explanation out of this, we could say, okay, in this case, we want to very much reduce the amount of information that we can want to provide to the user. It's like, okay, the input user and the input item are a good match because the input user is very similar to the first two prototypical users, as you can see from the similarity values in the vector. And these prototypical users are compatible with the proposed item. And this is basically the intuition behind our approach prototype-based matrix factorization, which will leverage user and item prototypes to provide both effective and explainable recommendations. I think you've heard matrix factorization enough for today, but I will just be very quick. We associate a user starting from it, since our model is based on matrix factorization, we associate we have an embedding associated to the user and the items. The recommendation score is simply the dot product of the two. And this learnable embedding can be optimized by any recommendation loss. In our case, what worked well was a simple cross entropy over the interaction data plus some regularization by the L2 norm. Now, starting from this, like the first step is to, what we try to do is to, first of all, to introduce the user prototypes. In this case, we have the user prototype matrix factorization, or user ProtoMF in short. And here, like following the same schema as before, we have, before computing the final recommendation score, what we do is to first take the user embedding in this case, and compute the similarity with the several prototypes in the systems. These prototypes are learnable embeddings that we learn together with the system. And in this case, we use a similarity functionalized as the shifted cosine similarity. Then, with this new presentation, in this case, like U star, we can compute the final recommendation score, computing the dot product with the item embedding. Of course, making sure that dimensionality match. And now, as we can see from the final score, this is, in the end, a sum of values, and each value is the contribution to the final prediction given by the prototypes, or given by the user prototypes. In the same way that you would say that for linear regression, at the same time, you have a sum of values, in this case, input times rate of change. In this case, the input being the similarity value and the rate of change given by the item embedding value, weight. We can optimize the systems, again, by using like, the same loss as before, but considering two interpretability, two additional regularization losses that force some sort of inclusion criteria on the embeddings that we are looking for. So, and to make it short, like what do these losses do, especially helping the stability of the system, is to force the users to be close to at least one prototype and the prototype to be close to at least one user. Of course, everything tuned by some lambda parameters. We can also, of course, define the same from the point of view of the item prototypes in this case, following the same schema as before. I don't think I have too much time for this one. So, but in this case, it follows the same schema as before. We compute the similarity between item and item prototypes. We compute the final recommendation score as a sum of contribution coming from the prototypes. And in the end, we optimize the system with a similar loss. Now, as a final as a natural extension, like we have the user prototypes on one side and the item prototype on the other, a natural extension would be to combine both under the hood of the same model. And this is what we did for the user item ProtoMF. And in this case, like the score can be given by the sum of the score coming from the two models. And again, like I want to stress, this is a simple sum, because in the end, we want to trace back the final recommendation score to either the user prototypes or the item prototypes. So it should be no linear. We can share the embeddings between the two models. In this case, they don't need to define too many additional parameters. In this case, by defining some linear transformations. And lastly, we can optimize the user item ProtoMF by considering the sum of the two losses. Of course, considering the recommended system loss only once. To test the effectiveness of our system, to test like our systems, we evaluated our approach on datasets on the music domain, on the movie domains, on the video games, on Amazon domain, on Amazon, and we compare our approach with matrix factorization, of course, but also like two prototype-based recommended system approaches. One is called representative-based matrix factorization, and the other one is a recent approach called anchor-based collaborative filtering. Of course, we compute accuracy metrics in this case, NDCG and Hit Ratio at several levels, check for the statistical significance of our improvement, and perform extensive hyperparameter optimization of both the baselines and our models. Now, taking a look at the results, in this case, I will show you only for the ones at 10. What we see is that the three ProtoMF models are able to perform better than the matrix factorization approach. And in particular, like the user item ProtoMF, that the last one I introduced, is able to outperform like factorization significantly on all three, on both metrics on all three data sets. And among the baselines, like the most competitive one is ACF, the recent approach anchor-based collaborative filtering. And what we notice is that our user item ProtoMF is also able to outperform ACF significantly almost everywhere, for the exception of Amazon Video at Hit Ratio. And similar results can be seen also for the other levels. Now, looking at how to explain the recommendations, like in this case, focusing on the user item ProtoMF, since it's the one that indicated by the results to be the most effective in providing explanations. I'm showing you here, for example, the contribution for the prototypes for a single recommendations. For example, and on the left side, you will see the contribution of the prototypes on the UProtoMF, so the user prototypes, and on the right, the item prototypes. And you see several bars, each one indicating how much the prototype had an influence on the final prediction. And depending, of course, on the context, like on the target audience and a specific explanation goal we want to optimize, we can then generate the final explanation. For example, if we want to focus on the transparency of trust of the user, and we want to provide a short information to the users, what we could say, okay, notice that there are some prototypes, like on the left, 53, 40, and 37, they contribute most positively to the final recommendations. We can then take a look at the interpretation of these prototypes. In this case, I'm showing you one approach and in terms of the related items, and then provide this information at the user. For example, like you are very similar to a person that prefers comedy romance movies, and we recommended this movie, that in this case, Pretty Woman. That was everything that I had to say. Thank you very much for your attention. We share the codes, the data splits, and all the experiments. I had to cut a lot, so feel free to ask or check the paper. I invite you to check the paper especially. And again, I want to thank you for your attention.
Thank you, Alessandro. Thanks, Alessandro. So there's a lot of interest on, so I'm going to try to cluster some of the questions. Yeah. The first cluster of questions is about where the prototypes come from.
Yeah.
Are they, so people are asking, are they predefined? Is there clustering behind it? How are they generated?
Yes, okay. So the prototype in our approach, they are learned during training. So in this case, the prototypes, they are defined as a placeholders, and we expect them to capture consumption patterns that are in the system, in the datasets.
So it's something you optimize via gradient descent?
Yeah, basically yes. It's like optimization plus considers the inclusion criteria that we defined before.
Does the number of clusters, does it have a big impact? Is it very sensitive to that? Or the number of prototypes, sorry?
Yeah. So it actually depends on the data sets, what I especially noticed for some data sets, and also depending whether we want to describe the users or the items. Items, what I noticed is that are easy to put them in a bucket, or like put them in specific prototypes. But for you, the behavior of users is usually more complex and requires more prototypes.
Okay. Very clear. Thank you for the clarification. So the other big cluster of interest comes from people asking about interpretability and explainability. So are these prototypes interpretable, and could they make recommendations more explainable? This is probably more for future work, but your thoughts. Yeah.
Yeah. This is a bit difficult, not difficult question, but it's too, I would say, maybe vague, but I will try to answer it. So the prototype, because especially it's difficult to, in explainable AI, explainable recommender system, there is a lot of overlap between the several definitions of what is interpretable, what is explainable. Let's say that I will try to answer that explainable, the recommendations, like the model is explainable in the sense that in terms of the algorithmic transparency, you can see and trace back where the, in a reasonable time, where the recommendation comes from. instead of like the prototypes are interpretable, I would say yes, because you can then query and understand what's behind the prototypes, or what patterns of items or item features these prototypes resemble. Of course, taking into account that there may be prototypes that are more difficult to interpret than others.
Okay, thank you. Thanks a lot. Thanks for the great answers in the next presentation. And then we're going to move on to the next presentation.